Hello everyone, this is Uma Mari, an assistant professor from the Department of Pharmaceutics, Supercrtcal College of Pharmacy. Today we are going to have a demonstration on supercritical fluid extraction. So what is the supercritical fluid extraction? Supercritical fluid extraction is the process of separating one component, the extractant, from the another using the supercritical fluid as the extracting solvent. Extraction is usually from a solid matrix but can also be from the liquids. Supercritical fluid extraction can be used as a sample preparation step for the analytical purposes or on a large scale to either strip unwanted material from a product or collect a desired product. These essential oils can include the limonene and clove oil, etc. Carbon dioxide is also the most used supercritical fluid, sometimes modified with the help of co-solvents such as ethanol or methanol to increase the solubility of the required material and to get a extra or quantitative extraction of the material. Extraction conditions for the supercritical carbon dioxide are above the critical temperature of 31 degrees Celsius and critical pressure of 74 bar. Addition of the modifiers may slightly alter this. Now we will move forward towards the assembly or the different parts of the supercritical fluid extractor machine. This is the example or this is the image of the supercritical fluid extractor. First of all, this is a CO2 cylinder which holds the CO2 into the liquid form. Second one, we have a monitor here which will monitor the different temperature and the pressures of the whole system. Next, we will have an co-solvent pump from which or through which we are pumping our co-solvent, that is ethanol or methanol, which is used for the process of the extraction. Next, we have a compressor chamber or compressor vessel. Here we are going to compress the CO2 and we are going to separate our main extracted product and the solvents. Next, we will have an extractor vessel, that is the extraction chamber. Here we are going to put some of the powder into a bag and we have to put the bag into the extractor vessel. Next one, that is the CO2 pump. Through this pump, we are going to forcefully add the CO2 to the extractor vessel with the pressure and specific temperature. And this one is the chilling bath which is required to cool down the temperature of the CO2 pump. This is the whole assembly of the supercritical fluid extraction instrumentation. Next one, that is how we are going to use that supercritical fluid extractor. For it, we have a specific type of SOPs, that is the standard operating procedures. First of all, we have to start the chiller bath and we have to wait till the temperature to attain minus 15 degrees Celsius. Second one, that is we have to fill the sample into the tea bag and this tea bag we have to place into the extractor vessel and we have to close the lid tightly because there is a presence of a pressure. Next one, we have to release the CO2 from the cylinder. There we have a two valves. First one, that is the main valve, and second one, that is the secondary valve. Whenever we open that first valve and second valve, there is an release of the CO2 from the cylinder. Next, will require the pressure setting. Here to set the pressures in the required limits with the help of the monitor, that is for example 120 bar for clove oil extraction from the powder. Next, we have to keep CO2 pump to the auto mode and the pressure is attained at the specific level. After setting that CO2 pressure or pressure is attained, we have to set the temperature of the extractor and the separator, which may vary or we can control with the help of the monitor. Then we have to set the plate heater at 50 degrees Celsius. After the extraction is completed, collect the sample from the separator vessel. After collection, we have to stop the CO2 pump and stop the CO2 cylinder valve followed by the first valve. Next, when the pressure reaches to the zero, the pressure controller stop the mains of both chiller bath and CO2 extractor. We have to remove the powder from the vessel extractor. Next, we have to turn off the chiller bath and the CO2 extractor and we have to release the second valve pressure, first valve pressure to attain the normal pressure of the system. When the pressure and the temperature reach the set value, set the mercury bulb position between 9 to 15. If the mercury bulb rises above 15, then pressure should be released from metering valve, and if mercury bulb is below 9, then tight the valve. So this is the whole assembly, principle, working and the standard operating procedure for the supercritical fluid extraction. Thank you.